We're going to start, like I said, with a presentation from Tom Ashley from Voltera. So this is understanding the demand side for these flexible interconnection pilot programs. So Tom leads Voltera's policy, regulatory, and government and utility relations strategy and engagement, and his work focuses on growing the EV and EV charging markets, connectivity to grid, advancing fleet electrification, and more, working in partnership with government and the utility community. So Tom, thank you very much for joining us today, and I'm going to pass it over to you for your 10-minute presentation. Thanks.
All right. Keep me honest on the 10 minutes, please.
Will do.
Well, thank you to the working group for the invite and the opportunity to share some perspective. I have a number of slides today. Some of them I might skip depending on how we're doing on timing, but welcome questions either during the session or as a follow-up related to slides or this topic. My contact info is in the slides that I believe will be sent around at some point. So please don't be shy. I know a lot of us know each other already, but look forward to engaging with folks who I haven't yet. Okay, so there's a lot to talk about here and more than can be done justice to in 10 minutes, but I'll kind of start with the high level. Definitely aware that a lot of people don't know about Voltera. Voltera only launched in 2022. Thus far, all of our sites are private access, and so we don't, for the most part, do ribbon cuttings or even really announcements. Um, and so definitely understand that we've been operating under the radar. Voltera was really born out of, for better or worse, a data center company. And sort of a unique set of circumstances that presented themselves and kind of the challenge associated with supporting the types of power access, real estate access, et cetera, that's necessary to enable fleets to electrify, at least via new facilities. And we can talk more about converting existing facilities. I'll just note Voltera is 100% owned by a private equity firm and our employees. So kind of a unique view of the private investment space. And I'll just say that, at the end of the day, we consider ourselves infrastructure investors beyond all of the other things that we do to enable infrastructure access for our customers. You see a little graphic at the bottom. So even though we're only, well, not quite 3 years in, we have 8 operating sites, and that translates to a metric that we use rather than chargers, but charging stalls. So over 200 of those, and we have one site that is kind of going through the throes of development right at the moment. Hopefully, it will go online next month, and that will put us over 300 stalls and over 30 megawatts of charging capacity. Next slide. Oh, and sorry, this image that you see on screen is of a facility in Dallas that we went live with earlier this year. Next slide. So I'm sure you've seen versions of this map from, various infrastructure companies. Check back next week and this may look different. I will just share that it will look different after our next board meeting. We are going to be looking for approval to expand our footprint and in some cases get a little bit ahead of our customers, which is a very fine line that we and others in our space walk. But one of the primary motivating factors for getting at least a little bit ahead of our customers is indeed what we're going to be talking about today, kind of the reality of bringing meaningful power capacity to enable charging facilities. I do just want to acknowledge that all of these green dots are real and live, with the exception of Miami. That is the one that is scheduled for next month. And the black dots are not necessarily coming soon. They're in various stages of either development or exploration. And I realize that a lot of the folks in this group do not have their jurisdictions represented on this map, at least with dots of any kind. Um, I, we're not going to be everywhere because our customers aren't everywhere, but definitely expect to fill in this map over the coming years. Next slide. So yeah, I'll speak to this a little bit. So I'm going to zoom out for a moment. So this is an actual project concept. Big caveat associated with this project. It was selected for funding as part of the Department of Energy Supertruck Charge program. It was announced for award of $22 million in January. And I'll just say that funding and this project is on pause until things get a little clearer with the release of that funding by the current administration. So just to flag that this project may not happen depending on decisions that are made by the Department of Energy over the coming months, potentially even into next year. That said, this is an example, and part of the reason why I wanted to include this is an example of thinking about a form of flexible interconnection from the get-go, from project concept, with the expectation that over time we'll be able to gather more grid power to the site. And I will also just offer the caveat that there are some technologies associated with this project that are truly uneconomic. And so it really is the grant component that made those elements practical for Voltera and our project partners to consider. What I also want to acknowledge, so this will be an example of kind of from the get-go thinking about flexible interconnection. But I think the reality that Volterra is seeing with our fleet customers and prospects, and I think most of our cohorts in the infrastructure development space are also seeing, is a need to think about flexible interconnection not necessarily from the get-go, but in reaction to the reality that our utility partners are facing on the ground with their distribution systems and implicated upgrades to serve the types of loads that our customers represent. And so I do want to acknowledge, first of all, um, my view is that everyone you talk to and ask how they would define flexible interconnection, they're probably going to give you a slightly different answer, even in California, where the commission and utilities have been fairly meaningfully engaged on this topic. I do also want to just share directly that over 10% of my colleagues at Volterra are involved in some form of temporary interim backup power. So not necessarily 100% of their time, but there's a lot of solutioning that we and others in our space are involved with. And I'll just say that, our hope is to never need to use temporary power or interim power, or to maybe never need it again. But I don't think that's, kind of what we're seeing in the industry. So happy to follow up and answer questions about that. But let me give a quick look at this project. And one of the reasons why this project was we were able to get creative about the approach to capacity, charging capacity, kind of smaller feed coming in from the distribution grid, is because we don't have a customer committed to this project. So the big constraints that Voltera and others in our space have around these projects are our customers and their operational requirements. And I think what has surprised a lot of stakeholders, including in some cases our utility partners and their regulators, is what our customers are asking for or need. So I'll talk more about that, but the high level that I communicate to folks, and this is across segments, which for Voltera is primary light duty at the moment, based on the changing market and policy environment for the heavy duty fleet space. Customers have a date certain that they are looking to energize a site and start charging operations to bring either new vehicles into a market or to transition existing vehicles to electric. So I realize I'm blowing through the time just with this overview. So I'm just going to do a really quick preview here. The short story for this project, and you can go to the next slide, Julia, is that we are envisioning bringing over 12 megawatts of connected charging capacity onto a site that is being served by less than 5 megawatts of grid power. So that is augmented by 3 megawatts or megawatt hours of battery storage, and includes a whole lot of different control mechanisms to manage load. And one big message I did want to share with this group, you'll hear from a couple California utilities. I don't want to suggest that what I'm about to say is completely par for the course and commonplace in California, but I will acknowledge that it's pretty commonplace for Voltera, and that is basically installing more nameplate charging capacity than is being served to the site by, let's call it, nameplate grid power. I'm not going to have too much time to share a lot of color on why that is, but what I will just message quickly, and maybe we can go to 2 slides forward. So I have a few slides in here which are examples of information that we provide to our utility partners to help educate them about our customer needs and what they can expect in terms of the load at a site. And these are what I would call constraints or guardrails. So high level, Voltera and our customers are open to certain forms of flexible interconnection, by and large, that allow sites to come online faster. But I won't speak to it here, but the slides and the various graphs, images, etc., basically speak to the constraints that we and our customers have in terms of how low the power is that we can sort of accept to be able to go live with the site and meet the customer's needs ahead of, in some cases, their transition to different vehicles that charge at higher powers. So let me stop there. I realize it's all a big tease. I hope to have the opportunity to share a little more perspective in the Q&A.
That's great. No, I appreciate that, Tom. Thanks for teeing this up. I definitely think this will generate some discussion during the Q&A. And if anybody has questions they want to not forget about, please feel free to just enter them into the chat to remember them. Next, we're going to go to a presentation from Alex from PG&E. Alex leads PG&E's Clean Energy Technology Platforms team, which is responsible for a portfolio of strategic initiatives to integrate DER's flexible loads and other edge technologies into grid operations. PG&E actually has a pilot program for this flexible interconnection, and now we get to hear about that from Alex. Thank you, Alex. Please take it away.
Thanks. I'm excited to be here. I hope everyone's having a good summer. Here in the Bay Area, it's more like winter. Enjoy your hot weather. I'm waiting for it to come to me. If you go to the first slide, I'll just kind of set the stage. I think Tom did a great job of kind of the problem statement. Like, why are we thinking about flexible service connection? It's really because we're seeing this unprecedented growth. At least in California, and our system has been relatively flat demand for many, many years. And so we have a fairly constrained system. And now we're seeing a lot of growth. 25% of all new vehicles sold in California are electric. And we're seeing growth drivers from other areas as well. And so we have a lot of areas on the distribution grid that are constrained. And so when we have a large new customer coming in, it could be a public fast charging, could be fleet, could be other load growth. There are often areas where we don't have capacity, and it's going to take some number of years, 2 to 4 years plus, to build out a new substation or different types of upgrades to serve the full load. So that's kind of that was the background, and really led us to think about, well, how do we meet our customers and really the speed to power. And so we developed this idea of the flexible service connection as a bridge, aiming for some customers, those customers that are able to receive a signal and adapt to constraints, to be able to connect sooner, more of their loads sooner, while they're waiting for the service upgrade. And so there's a value proposition for the customer. The customer in this case would be the new load application, or the new customer that's looking to increase their load. There's value for the distribution utility in that this is demand that we otherwise wouldn't be able to serve. So it's actually more megawatt hours in, and that has a downward pressure on rates by kind of bringing more dollars that otherwise wouldn't have been brought into the system. If you go to the next slide, I'll give a bit of more of an example of how this benefits a customer. So this is an actual case of a public fast charge, a 3.8 megawatt site where they applied for service. On the left, you have our kind of the standard review process, so kind of industry standard planning processes where you're looking at what are the kind of worst scenarios, because we plan the grid to meet all scenarios. And so this site was given a load limit, and so they were allowed to come on, and we basically said you can connect in the summer months, you can connect 20%, 700 or 70 kilowatts of that 3.8 megawatt, and in the wintertime you can connect up to 2.2 megawatts. And so that was the that's almost like the first version of a Flex Connect, is you can connect some of your load but not all of your load, and seasonal limits. But we went more in depth into say, well, how often, and not guaranteed, but how often are we actually meeting those constraints? And for this particular site, and not every site is like this, there's a lot of different types of pictures, but this particular site, we can actually serve the full 3.8 megawatts over 90% of the time. And so that's kind of what we're solving for, is to say, okay, we're not going to be able to serve your full 3.8 megawatts every day, every hour, but if you can receive a signal, we will tell you when you're when we have the constraint, and if you can respond to that, then you can connect the full 3.8 megawatts. So that's the kind of the gist of it. If you go to the next slide, kind of gives a little bit about how it works. And so in this scenario here, we've invested in a distributed energy resource management system, or a DERMS, which is a platform, a grid management platform. And that provides that, it kind of sucks in a bunch of operational information about our system, and it provides a day ahead forecast. to our operators to say, all right, well, this is where we can expect overloads. So that determines a site limit. So this new customer who came in, who's kind of signed up for our Flex Connect program, is able to receive that signal. So our DERMS combined with our advanced distribution management or ADMS system performs this day-ahead hourly forecasting of the available capacity on the circuit. And then it communicates that to the customers, what's often referred to as a dynamic operating envelope, using a standard protocol, which is IEEE 23.5. It communicates to the site day-ahead hourly limits. So those customers who have flexible loads that could be, and they could, maybe the load itself, the demand could be flexible, or it could be that they have local generation or local storage that provides that flexibility. The customer needs to be able to receive that signal, that day-ahead hourly limit, and translate that into some control action locally on their site. So that could be, if you're a charge station that has 50 chargers and you need to go back to kind of 50% of your demand, there's a number of different strategies that the customer could use there, by kind of feathering the charging or reducing the output of half of their chargers or reducing all of their chargers 50%. That's kind of on the customer to determine how they will meet what control action they will take. If you go to the next slide. And this is an example of, I would say, a great example of a success. And so this is a particular, and the type of benefits that a customer gets. This is a Pepsi distribution facility. They have 50 semis, and their requested capacity was 4.5 megawatts of charging. They have a limit. They have a limit overnight, and then they have a limit during the day of different varying levels. And what we've been able to provide since they've joined this pilot is an incremental 738 megawatt hours of energy that they otherwise would not have been able to get. For them, that translates into the ability to reduce cost on gasoline cost, diesel cost, so there's a savings on their side, and then they have a greenhouse gas emissions goals associated with the site. So this is just an example of one site. To date, in our program, we have five sites that are currently live in the receiving these day-ahead limits, and that's been over 2 gigawatt hours of incremental load served. For these sites, they've had 90% of the hours of the day, they're getting additional capacity over what they otherwise would have. And it's growing. So it hasn't grown as fast as we had originally anticipated, but we have 23 projects that have kind of signed agreements that are in development, and we're reviewing 12 projects a month. So we're seeing a lot of interest in this. There's quite a steep learning curve, I would say, on customers understanding what it means to have a flexible connection. It's quite a different paradigm shift where customers are used to having, kind of always on the same, like you apply for 10 megawatts, you get 10 megawatts any time of the day. And so there's definitely a learning curve customers are going through. We go to the next slide. So there's a process that we're looking to standardize. It's not standard yet. Right now, we're identifying we're kind of catching sites as they go through the normal service planning process. So a customer applies for service. And so we're looking to standardize what is the on-ramp for sites that might be in constrained locations, as they apply for service. That's kind of the reactive mode. But we're also proactively engaging with key customers and key segments, in particularly in the electrification customers who both have flexibility and kind of large demands coming online. And then we go through a process to produce those heat maps to say, well, this is what you can expect from your flexible connection. How often, how many hours of the day, how much capacity and how many hours of the day can you expect to get? So that a customer can then make a decision on whether they invest in the technology and the capability on their side to be able to kind of implement, to receive these signals. Then there's the long period of build, right? So each of these sites, these large sites, take months, years to develop on the customer side, and then we go into operations. So we go to the next slide. So one of the reasons why I think it's a little bit slower is the customers have new responsibilities here. The customers need to be able to receive a signal, and they need to be able to translate that signal. And it's a standard, IEEE 23.5. They need to have the technology and work with we have a number of aggregators or technology providers that have gone through this interoperability testing. So they need to be able to put a new box, a new widget in their control on their site to be able to receive this signal, and incorporate that signal then into their operations. And so that's kind of that is the customer's responsibility. The condition of connecting to participating in this flexible connection is that they need to be able to receive that signal reliably, and be able to respond to it. And so that's done through the technology enabler. If you go to the next slide, that gives an illustrative configuration. And so this gives an example. So we have let's say there's the constraint that we're managing toward might be at a substation. We are providing, if you go kind of the dotted line, we have monitoring of our constraint. We're forecasting that constraint, and then through the IEEE 23.5 interface, we provide that to the local site. And then the local site, like I mentioned, translates that into whatever it is they have on their side. And that site, that could be, again, EVs, batteries, whatever they're using to provide that flexibility. And what we've seen so far is we have, I would say, a couple different flavors of sites that are most interested. And that is DC fast charging, that is fleet electrification. We have front of the meter batteries that are market participating, but are charge limited. So we're able to give them more charging capacity. We're also looking at, on the generation side, interconnected, flexible interconnections. So like kind of different flavor or different side of the same coin. And then there are a number of other customers that might be constrained, that might have local generation. So we're talking to distribution connected data centers, which is the minority of data centers, smaller data centers, and quite a bit of interest from many different customer types. If you go to my last slide, I have a couple kind of lessons learned. One prior. And some of the considerations, right? So I would say we are at the crawl stage of a crawl, walk, run. And I think that agility is really needed at this stage. Like the capabilities and kind of technology is evolving, the standards are evolving, and the customer expectations and customer understanding is changing. So on the customer side, they have to understand, like, how will they translate the curtailment command. And so if if you're a public fast charging, how do you communicate to your customers when they expect to pull up that there's going to be a fast charge, right? So they're having to think about what are the downstream impacts of a constraint that they'll have on their customers. They need to understand, and we're trying to simplify and standardize, like, from a technology standpoint, what do they need to invest in, and how does that alter their site designs? At what point can they build it into their standard site design, this capability? And so those are some of the things that our customer is thinking about, and it's new. And the things that we're thinking about, this is new for us as well. And so how good is our forecasting? How we're not used to managing customer resources in this way. And so we're building out our operational protocols. What are the different roles and responsibilities? And the fail safes. How do we understand if we lose communications to a site? What is we call it fail safe? What will happen? What are all the different failure modes, and how will that continue to operate the grid safely? And then I think there are also a number of, I would say, bigger picture future considerations. A big one being like, what about the next customer? So right now we're working on a limited basis for the large customer who kind of like triggers the upgrade. But there might be multiple customers that are that want new connection, or there might be existing customers that might have flexibility. So we're kind of scratching the surface here with this bridge solution, bridge to wires. But there's a lot of, I think, opportunity thinking on the future of what might a more permanent type of flexible service connection look like. Is that something that customers are interested in? Is that something that that might be more cost effective over time, rather than doing, what would it take to not do the upgrade at all in some scenario? So there's a lot. I would say that's why I think we're in the early stages here. But I think that there's a lot of opportunity here, and I feel like this is just one first step in a bigger process of more dynamic grid management using customer resources. So I'll leave it there, and I look forward to questions and discussion.
That's great. Yeah, thanks, Alex. I appreciate that. Appreciate that overview. We have one presentation left before we'll get to our Q&A. Roger from Southern California Edison is a principal manager of distribution systems and analysis at SCE, and he has spent his career in various engineering roles there. So I will pass it over to you, Roger, for our final 10 to 12-minute presentation, and then we'll be able to get to our Q&A.
Excellent. Thanks for that. You hear me okay? You hear me okay?
Yes. Sorry, I wouldn't unmute. Yes, we can hear you.
Sounds good. Thanks for the invitation. I'll just start with that much of what Alex described in PG&E, much of it applies to SCE. We took different approaches, but a lot of the reasons and the whys is really cover addition with what Alex described. But anyways, this is a pilot that we're doing for at SCE. So I'll go very quickly over the background. What are the requirements to participate in our pilot? The challenges, who's eligible, some early findings and successes, and then what are we doing in future technology advancements? So I'll get the first slide. So the first back, so really the background equivalent to what Alex describes, really a significant increase in load within our service territory that is causing certain areas of the grid to be constrained. We are, as many of you know, we are the grid upgrades that are needed to meet the demands. They take in many cases many years. So we're working on doing that, but at the same time that takes years to complete. So we needed to come up with something, a bridging solution, if you will, for while the grid upgrades are completed. And by doing that, then we can, limit or reduce the timeline for energization, and then we can, able to serve as many customers as we can, from the distribution system. So again, we have this LCMS pilot, load control management pilot. It's a little bit different than what Alex described on PG&E. I'll go through that. But essentially what it is, it's customer agrees to install a power control system at their site to limit power usage based on a pre-approved schedule that we determined during the engineering phase. Each project is going to be different. The limit, it's going to be based on the load profile. So the most limiting component sometimes is the distribution circuit, sometimes is the substation. In some cases, it may be a higher level voltage. But nevertheless, that's essentially what it is. Customer installing a piece of equipment that we review and approve, and sets control limits based on what we approve. We go to the next slide, please. So as far as what the pilot, the goals of the pilot itself, and this is a pilot, it's a 2-year pilot that was approved by our California Commission in early 2024. So it's 2-year pilot is going to end at the end of this year. So really, what do we want to find in this pilot? And really for us was really, are we able to energize customers ahead of grid upgrades without causing a grid safety event? And again, we're relying on customer equipment. So, that area we were not, we needed to test that. We wanted to test the functionality of various types of control systems, So, we're having our goal of about 15 projects, 3 different types of LCMS integrators at minimum. That gives us a good amount of information to evaluate really the first question. And then really, continue to develop our communication-based technology, which is mostly what Alex was talking about, getting telemetry, getting bidirectional communication. Some of our research activities, again, that, determine, the load control is a load control technology, has reached a level of maturity that we can rely on to maintain grid safety and reliability. Being able to test the functionality of these power control systems to be able to meet, the safety requirements. And then how do we, what is the process to verify operational performance and make sure that we can approve the technology? And then finally, understanding how we respond to unintended grid contingencies. So we're relying on the customers having these controls at their facility, but how do they react to an emergency that we may have in the grid, and what is their response time for that? Next slide, please. So what is the eligibility for projects that participate in this pilot currently? So Alex also touched a little bit about this, but really for us is we only look at customers that have submitted a full energization request to SCE. And the first thing that we do when energization request is submitted is we do an engineering analysis to determine whether we have capacity to serve or not. If we have the capacity to serve, then we provide the capacity that's needed, and that's the end of. There's really no need for LCMS at that point. But if the engineer determines that we cannot meet the energization timelines because of distribution upgrade, then that would add to the eligibility of projects. We also look at determine whether we have capacity. We have we have a profile by which we are able to actually give customers some capacity. And if that's the case, then customers need to agree to enter into an LCMS pilot with the capacity that we have provided. So in the engineering analysis, we would determine what the capacity is. Currently, we offer 3 seasons. Each season has a peak value and an off-peak value. And if the customer agrees with that and enters into this agreement, and then they agree to put a power control system that we review, that we approve, then at that point we energize the customer, with those limitations. And again, if telemetry is, telemetry or communication is, developed during this pilot, we probably will also add that as part of the requirements. Next slide. So some of the challenges, the first one really is that we did not have a national standard for technology of this type. So, early on in 2023, we took it on with our engineers to review the control systems, develop testing processes, test the equipment, and essentially certify the equipment, through SCE's practices. But really, that's way too much, work, very taxing in engineering, and also the customers. So in parallel to that, we participated and pushed to the development of a UL standard, Euro 3141, which was issued in October of 2024. And so now we're sort of pushing our customers to use this control system that can be certified by a national lab, as opposed to us having to do the certification. The other thing that we had challenged was, we didn't really have good operating practices as to how to deal with contingencies. So we had to develop internal operating practices that our operation folks can take on in case of contingencies or in cases where the PCS does not operate as intended. And then we need really have a good regulatory mechanism. So to that end, we requested and we file and receive a PUC, a California PUC approval to do this pilot for a 2-year pilot, if you will. Next slide. As far as where we are today in our pilot, again, we're about 6 months away to finalizing the pilot. So this is what we've done so far. We have had 6 projects that have been energized through this pilot. 5 have been EV charging stations. 1 has been a non-EV. 2 of the projects have exited the pilot. What I mean by that is that we completed our grid upgrades, and we then terminated the agreement and disabled the LCMS, and we gave them their full requested capacity, quote unquote, the bridging solution. We have 3 other projects that have signed the agreements, and now we're just waiting for the transformer and equipment to be installed, and then we're going to energize them. And then we have about 20 other projects that we're currently working with applicants to determine whether they're going to go into the pilot or not. We have worked with 4 different integrators. Again, the goal for us was a minimum 3. We have a 4 now. And early findings have showed that so far controls have operated as intended, meaning like they have not exceeded their limits. And again, as I said earlier, we are now pushing toward using 3141 certification, for these control systems. And I would say, and then finally, we're working on the technical requirements. I will say a success for all of you those of you are familiar with California and Nevada. One of the big things that really help here is the transportation corridor, or the I-15 that goes from California to Las Vegas. We have a lot of constraints on that area, and we were able to use load management technology to sort of allow many of those charging stations along the 15 freeway to be energized and provide charging services to, folks that are moving going from California to Las Vegas. And then the last slide, I think, if you go to the last slide there. As far as advancing technology, so the left portion of the screen, that's where we are today, which is really just us providing a limit to their customers, to their control systems. And then we verify performance through the AMI meter. So we have a monitoring system that we check to make sure that they are staying within their limits. And if they're not staying within their limits, then at that point we take action. So far we haven't had that condition, which is great. So we want to keep it that way. But moving into the future, probably in a couple of years, we'll be moving closer to what Alex is talking about in his presentation, which is a dynamic limit based, sent via 2030.5 to a QL3141 control device at a facility that can then be managed with higher level of granularity. So that's probably more of a couple of years out. And that's it for me. So look forward to hear any questions from you.
Fantastic. Thank you. Thank you to all 3 of our speakers. So we can maybe take the slides down, and all 3 speakers can come back on camera, and we can move to our Q&A portion. There are